Then we see the idea of how to parameterize the system and the difficulty that is coming out of the parameterizing the system. And there are two cases, the same way that we did it before, minimum phase system and non-minimum phase system. We are going to do the minimum phase system, the non-minimum phase system, we are just going to describe it and see how it works. Then we see the general design issues that are going to come with the fact that we go directly with the estimation of the controller. So basically what we have seen in our calculations before, when we go from accepting all the zeros or rejecting all the zeros, we find out that the calculation becomes a little bit more complex. We have more equations to solve. The equations are not as straightforward when we do with full cancellation. But we have seen that if we accept and we say that there is a full acceptance of all the zeros, then we may end up by a control that it would be also oscillating, and then there are some positive and weaknesses to every decision that we are going to take, and we would like to see how we can avoid this by the system here. The second thing, we have seen that in the previous way we were working, we are identifying the system, and then we identify B and A, and based on the value of B and A, we are designing the controller. And then we are repeating this at every step, right? And then we are assuming that the signals that we are getting in the identifications are rich enough in terms of persistency that they will allow us to identify these values of A and B. But in real life, they could be not the case. So in real life, the way we go around it, we inject artificial noise in the input, and we see if the system, we can add more excitation to the system. But for mechanical system, for example, if I have a compressor and I add noise at the level of the input, the compressor will filter all this noise. You will not see anything of it at the level of the output. So maybe you will add the noise, but the noise is not enough to make sure that you are getting enough persistency in the signal. So this is why we are talking about numerical convergence and air-conditioned system based on the identification of B and A. So basically what we are saying that since this identification, this calculation can be time-consuming, can be a little bit sensitive to B and A, let's go and try to identify the value of the controllers directly from the identification rather than doing the calculation of the system. So what's the idea? The idea is that we reparameterize the system. So the system, we take it as is, and then we reformulate it again in order to make the controller appear in the difference equations or the recursion equations. So it becomes part of our model, and then after that we do the estimation to find the controller. So how to do this? So this is basically what we are trying to do. We take the input, which is the control signal, we take the output of the system here, we go through the estimation algorithm, and then from the estimation algorithm, we go directly with the parameter of the control. We don't have to find the value of A and B. And if I put a noise at the level of the input here, the problem of persistent excitation is exactly the same. So we need to pay attention to that when we are going to do the calculation for our controllers. So how we do this? So first of all, what we know is that the process model is governed by A times Y is equal to B multiplied by U of T. This is given for us. What is also given for us, latency in this, okay, the reference model. We know that the reference model is given, we are having AM multiplied by YM is equal to BM multiplied by UC. And from the calculation that we did, we were able to put the structure of the controller, and the structure of the controller has three parameters that are unknown, R, T, and S, according to this structure. So the idea is now work around this in order to make sure that the controller appear in the relation between Y and T. So we look to the characteristic equation. We know that the characteristic equation is equal to A0 times AF. This is AR prime times B minus times S is equal to A0 times AM. We divided B in two parts, B minus and B plus, still valid. All what we have done is still valid. And then we go like this. So, so what we do, we multiply, we take A0 times AM multiplied by Y of t, and then we are able to write this as equal to the same thing as AR prime Y of t plus B minus S times Y of t. So basically I take this equation that we have in the top, and I multiply by Y of t from both sides. Okay? Then since we have the equation here, we are able to, we know that A multiplied by Y of t is equal to B of t, we have in the top. We just replace it here in the equations. And we continue like this, and the equations. So at the end of the day, what we are going to get is a relationship that will give me A0 multiplied by AM multiplied by Y of t is just equal to B minus 1 times R multiplied by U of t plus S multiplied by Y of t.
Sweet.
So this equation here, the left-hand side is completely known because it's coming from our observer and coming from the characteristic equations. The right-hand side here, R and S are unknown, and B minus is also unknown, because we said that we don't know the system, and we don't want to know the system. Everybody is okay with this? So this is where the problem starts, the difficulty starts. The difficulty starts from the fact that we have unknowns in B, unknowns in R, and unknowns in S. And then if you multiply B minus is a polynomial. Huh? If you multiply it by the polynomial R, or you multiply it by the polynomial S, then you are going to have a cross multiplication of parameters of B minus with the parameter of R, or B minus with the parameter of S. Right? So when you have this cross multiplication between terms, the parameters are no longer linear. Remember when we did the least square method, one of our assumption was linear in parameters. So linear in parameters means that I'm able to write my system as a regression function phi of t multiplied by theta. So it appears linear. But right now the parameter theta is no longer linear, right? It's not linear, so therefore I would like to see how we are going to do this. And an example. If I take B as B0 multiplied by Q plus B1, and I multiply it by R, and I will assume that R is a first order system, so Q plus R0, like this, then what we are going to have is B0 Q squared plus B0 R0 Q plus B1 Q plus B1 multiplied by R0. Everybody is okay with this? So your parameters are no longer linear. There is multiplication between the parameters between each other. It's not bilinear. Yes?
Can we not call all of that a new parameter?
This is exactly what we are going to do. So what we are going to do, and we are going to integrate B minus with R and B minus with S. But remember, our objective is to find R
And
and S,
B.
not B minus times R and B minus times S. Our objective is to find R and S. This is our objective. So how we are going to deal with the finding R and S? This is the objective of our work. All right. So new process equation. This is the new process equation here that we are trying to identify. And in any new equations, for example, if I write a system like this here, Q squared plus B1 Q plus B0 multiply, or maybe A1 A0 multiplied by Y. This is just an example, multiplied by Y of t is equal, for example, another equation from the other side multiplied by U. Let's say B0Q plus B1 multiplied by U of t. Looking to this equation like this, I will not be able to work with it immediately as it is. So I need to manipulate it differently in order to work with it. So the way to manipulate it differently, we take this q squared as a factor, so q squared multiplied by 1 plus a1 q minus 1 plus a0 y of t. And then we take a q as a factor here, equal to q multiplied by b plus b1 multiplied by q minus 1 multiplied by u of t. And then I take this q squared and I will bring it here. So this will give me this equal to q inverse multiplied by b plus b0 plus b1 q minus 1 multiplied by u of t. So basically what we did, we converted the polynomial from a function of q to a function of q inverse. Okay. And the q inverse, we know that it's a shift to the right. So we are going to write this. If I take my system without this term, this will give me y of t plus a1 y of t minus 1 plus a0, this one is q minus 2, y of t minus 2. This has to be equal from this side to q minus 1, I'm going to keep it still, multiplied by b0 u of t plus b1 u of t minus 1, which will be equal also to b0 u of t minus 1 plus b1 u of t minus 2. So from here I can extract what would be the value of y of t if I know all the history of y and all the history of u. So I will be able to predict what would be the value of y of t. So I can say here y of t, this is my new value, based on all the previous history up to time t, can be written as minus a1 y of t minus 1 minus a0 y of t minus 2
Like we did in
plus
this
b0 u of t minus 1 plus b1 u of t minus 2. Everybody is okay with this?
Yes.
Sir, this is like ARX or RMX model for the identification.
So repeat this again.
So this is like ARX or RMX model for the
It's an RX model.
ARX model.
Yeah. So, but for us, this is coming from this equation: a times y equal to b times q. Different models later on, you can see them later in the identification. But my objective of all what I did here is that just to show you the steps. The steps is to take the polynomial as function of q and convert them to polynomial as function of q inverse. Identify the excess and the shift, the excess and derivative. So we call this q to the power of minus d0. We have called it last time, d0 is the excess pose between the two. And then from here, I'm able to express this as the value of y of t as part of the past history of the value of y and the past history of u. Everybody is okay with this? So for us, in order not to be confused, we are going to put anything. For example, if I have a of q equal to q squared plus a1q plus a0, I'm going to say a star of, as a function of q, or q minus 1, the way you want, is equal to 1 plus a1 q minus 1 plus a0 q minus 2. So I took everything out as q as a factor, I generated a star. Everybody is okay with this?
Yes.
So we continue then our development. We say that our estimates are b minus r and s. This system is no longer linear in parameter, but it's not linear in parameter. We would like to find the control law. This is our objective. And then we are going to look to special cases, minimum phase system and non-minimum phase system, because they are the simplest one to cover. The difficult ones, we'll give them as homework as usual. All right, so the minimum phase system, we are going to talk about full constellation. Full constellation means everything I will put in B plus, right? But I need to put it as a monic polynomial. So the only thing that will remain in B minus is the constant, is B0. You remember this, right? We did this together. So what we have either direct solution of the Diophantine equation or modified pre-filtering. So I'm going to show you the two of these systems. So if we go directly with the Prefontaine equation, this is the Diophantine equation, A0 times AM y of t is equal to B minus R d of t plus S times y of t. But I cannot use it directly like this, so I'm going to convert it to A star later on. We will see this. First of all, we start by replacing B minus by B0, right? And then we include B0 in R and B0 in S, so we call them R tilde and S tilde. And our objective is to find this R tilde and this S tilde, basically from our initiative. Then we define the excess poles, which is degree of A minus degree of B. We check the compatibility condition, of course, as usual from the beginning. And then we convert everything to, this is minus D0, so Q to the power D0 AM of 1. This is the gain in steady state that we have done last time. I will come back to this example later. So this is exactly the same way we did it before. Then I convert, as I told you here, the system like this as A star and AM star. So this is what we did there. And this is equal to phi transpose multiplied T minus D0 multiplied by theta, where theta are my parameters. So for example, here would be, my theta would be A1, A0, B0, and B1. And the phi would be y of t minus 1, y of t minus 2, u of t minus 1, and u of t minus 2. Easy, right? Simple. So this is the Diophantine equation. So basically you take all these equations that you have there and then you reconvert them to Q minus 1 and then you extract your value of y of t with respect to the update that you have on the right hand side. But another way to do it is to look to A0 Q minus 1 and A times AM as a filter. So basically what we do, we divide by 1 over A0 times AM. We will have y of t divided by A0 AM. We divide y of t by A0 AM. I will call these two signals the filtered u and the filtered y. And then I will have y of t as function directly of the controllers times the filtered signal. This is a cleaner way to do it, right? The reason why it's a cleaner because the parameter of A0 AM, you know them already. You have them, right? So if you do all these calculations here, you will find out if you start with A0 AM times y, you will end up on the right hand side with parameter that you know and parameter that you don't.
Here, what do you mean by filtering action?
Filtering action, it's a filter. I'm taking u, I'm passing it through this filter. This is a polynomial, so it's a filter. I'm taking y, I'm doing the same thing.
So just a simple filter.
Same?
This equation represents just a simple filter.
It's a simple filter. So my question for you is the following right now. If I use this and I put it in the least square method, what I'm going to get?
B0 multiplied by
B0 multiplied, I'm going to get R tilde and S tilde, right? So how I'm going to get B0 or R and S?
We'll have to, when we get the expression still there is going to be B multiplied by the initial R and S. Then we can equate it to look for B or to look for the other side.
How can we equate it to get for the value of B? Everybody understand my questions?
Yes.
Or like,
yeah, how to
The
extract
question is
B0
clear?
from the
so we have included B0 in R tilde, in R, صح? And we called it R tilde. And we have put B0 in S and we call it
One of them is Munich.
S tilde.
One of them is Munich. It's supposed to be Munich.
One of them is supposed to be
Munich.
Munich. So
So you can take the coefficient out, then you have the Munich.
what will be the B0?
Unit coefficient.
The
with the
coefficient.
higher.
Right? So the value of R tilde is supposed to be monic. So when you do the identification, you are going to assume, of course, R is monic, but R tilde is not monic because you included B0. So you identify R tilde and S tilde, and the highest coefficient, or the coefficient of the highest degree in R tilde, this is your B0. So basically you need to get 1 here. If you get something other than 1, then B0 is that value. sense?
So is it possible to get a case scenario where we're getting different values of B0 from both R tilde and S tilde?
This is the excellent question. So who will guarantee that we are getting the same value of B0 from both sides? How are you guaranteed to are going to get the same value?
Again,
Your friend is saying there is B0 in R, B0 in S.
it's the same business.
It should be the same B0.
But in the identification, you can find.
You can find something different.
Can we find something different, sir? Well, I'm asking you the question differently. Can we find something differently? Do we care if they are different? So do we care if they are
How
different?
much
Is
are
a
they?
stronger question, sir.
We care. Yeah.
We care.
We care. We are going to make a slogan. We call it in 5 to 7. We care. Huh? Right. Who says that we don't?
Let's go back. What does B0 do here? How important is it?
Nobody? All of you, we care?
Yes.
والله قلبكم حنين. So why we don't? Anybody would like to take a guess why we don't care about B0 and S? What will be the exact value of B0?
He just like select S to be n-2, R as n-1. Then we get
What do you mean? Degrees?
degrees, yeah.
Degrees 1, 1. We will not complicate it. We will not make many things variable.
If we take, for example,
For the example that we took last time, 1, 1. Yes.
If the B0 is not the same value, it will be already in S0. The S0 will have to be.
This is exactly the answer. If B0 are not the same, then S0 and S1 will change. And we don't care if they change, since they are going to change with the same amount, then the 0 that is introduced by S will not change. So in other words, we don't care. Doesn't make sense? No? Okay, we have S equal to S0 times Q plus S1. And we don't know S0 and we don't know S. The 0 introduced by S is Q equal to minus S1 over S0. So if I multiply by V0, the 0 will not change.
Will not change.
So if I go here and I say, for example, I'm going to say that R is basically a constant, so it's B0, just B0. So I found R equal 1.8 in one of the examples, 1.8. So I'm going to come here and say S0, this is S0 tilde, let's say. Then I'm going to say S0 is equal to S0 tilde divided by 1.8. And S1 tilde is equal to S tilde divided S1 is equal to S1 tilde divided by 1.8. So the value of S0 and S1 will absorb the value of B0. If we try to compute the 0 back again, you will find it exactly the same. So in terms of the 0 introduced by S, it will not change. Now it makes sense?
Yes.
All right. So this is exactly what the algorithm will tell you to do. So basically, this is what we have. We start with the specification of AM and BM and the value of degree of A0. All the analysis that we did before stays exactly the same, which which means that the model structure of the plant is fixed, does not change. Everybody understand that? So we assume the plant, you don't know the plant, but you are assuming a model, but this model is going to be fixed during all the design period. So based on that, we identify what should be the value of V0. We write our system as part of the filtered signals, UF and YF. From here, we are going to run our identification algorithm, and we are going to find the value of R tilde. And from the value of R tilde, we'll take the coefficient of the highest polynomial, we take it as B minus. We put this, we identify R and S tilde. This is our controller. the value of t, we are going to find it based on a0, our selection here, multiplied by am1, which is the value that we have from our system. And like this, we are going to have all our algorithm done, and then we repeat the step for every iteration that we have. Everybody is okay with this? Now I'm going to explain for you just the filter case. So basically, if you would like to take an example from A to Z, we can do it like this. So our system we started with is B over A times U is equal to 1, and we selected this as B0Q plus B1 divided by S squared plus A1Q plus A0, or A0Q plus A1. And then we selected the reference model, Ym is equal to Bm over Am, and then Y multiplied by UC, and then we said that this is equal to the value of AM1 multiplied by Q to the power D0, at this time D0 is equal to 1, divided by S squared plus AM1 Q plus AM1 Q. So this is our reference model that we have selected. In terms of compatibility degree, we have degree of B is equal to degree of Bm. So these are the first compatibility condition that I checked. Degree of A is equal to degree of Am. This is also done based on our preference. Then we look to the value of B, which is equal to B0 times Q plus B1. And then we computed the 0. And from here we decided that the 0 can be completely absorbed by B plus. So we accepted the behavior of B0. So we said B plus will be equal to Q plus B1 over B0. And then B minus is equal to B0. Everybody is okay with this? This is what we did with the previous example. Now, according to my system here, I need to generate U filtered and Y filtered. So U filtered and Y filtered, this is equal to 1 over A0 multiplied by AM multiplied by U. Okay. And then this is the same thing. I'm going to put star here because I'm using the Q minus 1. Sure. Right. So the same thing here for the star multiplied by Y. The value of A0, we have the degree of A0 is equal to degree of A minus degree of B plus minus 1, and we found last time it's equal to 0, so A0 is a constant. So our case A0 is equal to 1. You are following what I'm doing here? You have no idea what I'm doing? Ramadan? Yeah, I'm trying to relax a little bit. I'm trying to solve the same example that we did before, but using the direct method. So up to now, anybody has a question? Maybe I did some mistakes. This is why you have questions and you are confused. Anything that it makes sense or not make sense?
S squared.
يا اس سكوير دي خلينا منها.
Q squared, right?
Q squared.
هذيك واضحة.
ايه
طبعا هذه ما هو لابلاس
صيام.
صيانة. رمضان. Thank you. You are okay with this? Yes. Nothing. UF and YF, what are they? They are the filtered version of U. So this is the filtered U. And this is the same thing for Y. So basically they are coming from these are these two, UF and YF, and they are coming from here. So we took this, let me go one slide before this. We took this A0 times AM, and we divided all over the right hand side of the equation. Here. A0 times AM multiplied by y of t is equal to this. I took this A0 AM and I put divided here. Well, so when I divide, I will have u of t divided by A0 AM and y of t divided by A0 AM. I call this u filtered and y filtered. By the way, this notion of filtered signals, we will see it later on when we are going to move to model reference adaptive controller using MIT rule. We will again work with the filtered signals. Up to now, everything is okay? Yes? No? Yes. All right, so we have the Diophantine equation. We have A times L prime plus B minus multiplied by S is equal to A0 AM. So if I multiply by y of t from both sides, I will have L prime multiplied by B minus. This is our equations here. I don't want to repeat the same calculations again. So we have B minus A0 AM multiplied by y of t is equal to B minus multiplied by R multiplied by U of t plus S multiplied by y of t. So in this case, B minus is equal to B0. But I'm going to call this all as RT multiplied by y of t plus ST multiplied by y of t. And if I take this and I bring it to the right hand side, I'm going to write y of t is equal to R tilde times y filtered of t plus S tilde multiplied by y filtered of t. So the R tilde is equal to B0 multiplied by L prime, and in our case our value of R prime is equal to 1. So R tilde is basically B plus. Right? R tilde is B plus. So if I identify R tilde, this is the value of B plus that I have. So based on the fact that R prime is equal to 1, this will imply R tilde is equal to B plus. And then we have S tilde is equal to S0 times B0 times Q plus S1 or Q minus 1, because I converted everything to negative. So this one SQ0 multiplied by B0 multiplied by Q minus 1. This is the value.
You filtered.
measurement.
Divided by A0 was star. Yeah. Filtered, it's already divided. Yeah. Star.
Are you okay with this?
R tilde is equal to B0 multiplied by R or
Yeah,
R
and the
tilde?
star.
R tilde.
We get
R
Q.
prime, not R tilde. R prime.
With Q minus 1.
R prime. So in our case here, the value of R is based on this equation that you have here. Same development that we did before.
The equation in the slides will be 0 R, not R prime.
Yeah, because we are assuming the equation from here. Multiplied by R, not by R prime, because we have B, we are right. So we have here L prime is equal to B0, this one multiplied by B plus.
Yeah.
Yeah. So we have here, this is B plus. And B plus is known, yeah? So L prime is equal to 1, so this will be B0 plus B1 Q minus 1.
For R prime, it's equal 1 because the degree. And
because of the degree. But the fact that we multiplied here by b, we took one of the b plus, we put it with r prime.
Yeah.
So this is why it became only b minus. So and this becomes r. So why I'm doing all this with you is just to give you the two filters that we need to implement, because at the end of the day there are two filters. The first one is how to compute u filtered and y filtered. So u filtered is equal to u divided by a0 am. I'm going to put star here again. So this basically u divided by a0 we said is equal to 1, am star is equal to 1 plus am0 q minus 1 plus am1 q minus 1. Right. So this is the relationship between u and u filtered. So if we take this and we multiply it to the left hand side, you are going to have u of t plus am1 u of t minus 1 plus am0 u of t minus 1 plus am1 u of t minus 2 is equal to
The u's on the left are filtered, all filtered, U filtered.
u filtered is equal to u. Everybody is okay with this? So from here I can conclude that u filtered at time t is basically equal to minus am0 u filtered at t minus 1 minus am1 u filtered at t minus 2 plus the value of u at time t. So I take the value of y of t, u of t, I take the two previous values of u filtered, and this will allow me to generate the new u filtered at time t. And this is the one that I need to use for the equations that you have here.
For the first step, first two steps.
First two steps, you have to
Put zero.
assume zeros. Right? Zeros or a shift, which is basically zero, or if you have
Without
data.
AM0 and AM1, right?
Sorry?
AM0 and AM1, they are known.
Yeah, no.
So what's the use of this whole formula? Since I know.
To calculate
You
you.
can
You
just-
calculate u filtered.
You filter?
Because u filtered, you have to put it here to find r tilde and s tilde.
On your controller.
And then control. Make sense? So this brings me to the code now. If I would actually show you the code so you can understand exactly how the code is working. So every time we have a filter, is basically we write it in the form of differential equation. Right? Difference equation, not differential, it's difference equation.
You have to use the filter, then you can estimate. The filter comes before the estimation of RT and ST. Then the yeah. Exactly. You do filtering, then
Alright, so we do exactly the same
RT,
thing.
ST, and then
So we take this is our reference model. Our reference model is basically we are using the sampling rate equals 0.5. We are simulating up to 100, and we are generating the input signal as a square wave. Here I'm generating the disturbance. You forget about the disturbance right now, we'll see it later. So we take our system, which is B over A continuous, we convert it to discrete, and from there I extract the discrete system. And I extract the excess number of points, which is D0. Here I'm doing it directly equal to 1, but I can see the size of the vector in MATLAB in both, and decide by the size of the vector what's the degree difference. I extracted what is exact in terms of parameters. And then I defined here my BM over AM. So I took omega n equal to 1, zeta equals 0.7, created the continuous system, discretized the continuous system based on the same circuit period. And after that, I took the, whatever MATLAB gave me, I ignored the numerator. MATLAB will give me a numerator based on the method that we have there. I ignored the numerator, and I replaced the numerator by only the value of the sum of the denominator, which is A of 1, AM of 1, as we have said it last time. So from here, I extract what should be BM 0, BM1, BM 0 should be 0, only BM1 is different. Identify the number of aggressors equal to 4. Lambda, we are putting it equal to 99. I'm going to put it equal to 1. And then continue. Lambda equal to 100. I need initial values, as your friend pointed out, because there are some shift in time. So I need to have the value of A0. I need to have the value of theta 0, which is A0 multiplied by AM1 is constant in this case. I take the value of the parameter of B and S random, and then I
B and S. Then parameter. Yeah.
are tilde and S tilde. Then we take initial value of Y and Y filter because we have one regression in time. I can generate one initial value of U and Y and one filter based on this regression, but this is basically assuming that t minus 2 is 0. And then I start my loop. And then the loop here, I have some work that I did, which is including the disturbance at the level of the input, so we ignore it. But this is the value of my controller based on my initial values of R1, R0, and T1, and the 0 S1. From here, I calculate the filter based on this U, and the filter, you see, it's the same equation that I did there. Right? So filter, which is just a recursion. Then from there, I get my Y estimate based on R0 multiplied by R tilde, or R tilde values and this tilde. I use the error, which is between my estimate and my output. This is my error. Then I generate my regression vector, my value of K for the least square method. I update my P0, computed the new value of theta. And then once I have the new value of theta, I need now to come back again from the beginning of the loop, from here. Right, so this is for my next step. And then it's a plotting the data. Everybody understood the code now? So the code, implementing the filter, there are many ways to do it in MATLAB, but we want one that can do it point by point. So there is a MATLAB function filter that allows you to create any filter you want, but we just use the equation. So these are the values of B's. They have been correctly identified, B0 and B1. These are the values of the S0 and S1, also well defined. Don't look to the eyes, because this is the same code that I used from the previous algorithm. So we are not identifying A and B, we are identifying the R tilde and S tilde. And from here you can see the controller is exactly the same as we had before with the ringing. The same thing. Now if you look to the performance in terms of time, this is the performance in terms of time. So the initial values going up to the sky because of the initial values. But after that, we have perfect model following. And in this algorithm, I did not compute any value of the process itself. A and B are not known for me.
That's the question. Why would we choose this method if it limits our let's say choice of the zeros? Because we're not taking any zeros. Yeah, B minus is only constant.
Yes.
So we're limiting ourselves.
So what will happen if B minus is not a constant?
We will not be able to.
Non-minimum phase.
Huh?
Non-minimum phase.
No,
Not minimum
RT
phase. But what will happen in all our algorithms that they show
RT
that-
then S tilde will be let's say bigger, and we will not be able to identify B0 directly.
So let me go
Can you
back to
change
what
the
I did
vector?
and B tilde, and you tell me what will happen. I would like you to think about it. Suppose that I don't cancel any zero. I put all of them in
B minus.
B minus. So I have R tilde will be equal to B minus multiplied by R. طبعا all of them star. We are talking about Q to the power minus something, all these polynomials. And S tilde is equal to B minus multiplied by S. So what will happen with all my calculations? Now B minus is not a constant anymore. It is a
Polynomial.
polynomial.
So you get the first coefficient, but the other two, or the other coefficient is hard to get.
طيب, okay, this is one way.
Change the filter.
Change the filter.
Or replace the filter to match with UT and SL.
Okay, but I have no idea what B minus is.
Yeah, the identification will
We
be
don't know what B minus is. So B minus is something unknown. We said that we don't want to identify B and A. At least up to now. I'm going to change it later, but I want to find B and A. So how I'm going to deal with this? For this one, it's easy. B0 is the coefficient of the highest power. It's easy to extract it, and then we continue, as your friend said. But what if B minus is a polynomial? What we have to do? First of all, the good news is that we can apply the same method. Yeah? That's the good news. So you are not confused. And yes, not limiting. But now I'm asking you if you were the one presented with this problem, this one here, where B minus is a polynomial and you are computing R tilde and S tilde with B minus times R and S. How can you continue the system? Or how you will deal with the system? What will change?
Easy.
Anybody would like to take a shot? How he will proceed?
Trying to finish.
I can assume it's Ramadan. It's okay. So what we do, we continue the procedure exactly the same. We don't change anything. Right?
What about the degree here?
The degree will be higher.
How do we separate them?
How do we separate them? This
Yeah.
is the question. We separate them by doing the following. We compute
Assume for
the zeros of R tilde. Compute the zeros of R tilde, and we compute the zeros of
still.
S tilde.
We'll find that the same zeros
The same zeros
are
are
the B.
R B minus.
But theoretically, they can have
Different.
the same zero, but it would not be. B.
R and S can have
Can have one
common
one
zero.
common zero,
Can-
except
Yeah.
for
We don't care.
we don't care
No, no.
How-
because we will take it off. It will
How
not
will
be in the
you share?
controller.
I will take it off. It will not be in the controller.
It doesn't matter.
I will not have oscillation in the controller. This is all what I want.
Yeah.
The controller is stable. As long as the different equation is equal to each other,
Yeah.
the dynamic that I want is coming. I'm having it, sir. Right? If you have A times R plus B times S is equal to A0 AM times BC, always very valid, then you are getting AM, the model that you want. The question is what's the quality of your controller? The signal, the input. So I need to take from the controller, I need to take out of the value of R and the controller all the zeros that I will judge underdamped. And for me, the underdamped would be the common zeros between R and S. Right. Are we going to get them exactly equal? With the unification? No. So we may find that if I look at it in the absolute value, there is no common zeros. So I need to put a margin, threshold. If they are less than this, then they are the same. Everybody is okay with this? So this is part of our work as a control designer. Yes, you have a question?
I was going to ask if, for example, if we computed the zeros of R tilde and S tilde, we find, for example, 3 common zeros, and then we have B minus, degree of B minus, for example, is 1 or 2. How can we get the?
There is an issue, huh?
Yeah.
So the real answer then, for some cases, we are going to be stuck because we are going to find probably contradiction between what we assumed and what we are getting. So the way to go around it is that we mix the algorithms. Mix the algorithm means that I will create a hybrid algorithm. The algorithm is not fully direct and it's not fully indirect. So I will use what we saw last time to estimate B and A, but I will not do any calculation in R and S, and I will use the value that I'm going to get in B and A to compute the value of R tilde and S tilde. Everybody understood that? خلاص أنا كملت اللكشر. All the slides they are talking about what we said right now.
I don't know homework.
Sorry. So basically this is what it is. So we are going to talk about so all these conditions have to be verified. They have to be consistent in my work all the time when I'm getting all these values. The filtering is very important because it allows you to remove also some kind of anomalies in the data that you have in here. This is the example that we have seen before. So the algorithm is, I will come back to this data, how to compute but this is what it is. We are going to compute the value of R tilde and S tilde, and this is the case of non-minimum phase system. And then after that, we cancel common factors between R and S. These are considered to be the B minus that you have here. Right? So this is one way to do it. The other way to do it is to mix the algorithms. So we use the algorithms to find A and B. By knowing B, we can compute B minus. So we know B minus from the beginning, and then we try to take it out from our equation of the estimation. Right. Now, in our algorithms, we are computing the value of R and S, and then T is given directly by our calculations. We are also able to include T in the identification. So we no longer value, but this is easy, right? We just add T as part of the equations that we have. So basically, we add T here with UC, we compute the error between the two. And rather than having the equation Y as function of U of T and Y of T, we will identify based on the error between Y of T and Y error. And T will be here. So T becomes part of the identification algorithm. It's one of the parameters that we need to identify. Does it make sense what I presented for you here?
Yes.
It does? All right. So this is exactly what we'll cover, and we'll finish this topic of recursive, not recursive, sorry, but polynomial controllers or RST controllers. What I'm expecting from you right now is to apply this. So we have two ways to do it. Either you take your algorithm and you modify it, and you put the new system and you try to see it. And I believe if you are able to program it, means that you understood the algorithm. So you are able to solve any other system, right? Because programming means that you put your ideas in orders, right? And if you put your ideas in orders, any problem after that is easy. And this is why I'm asking you to program, but I have the program and you have them also in the book. But it forces you to understand the steps, and this will be beneficial. So I would like you to reprogram the problem 3.6, the same problem that we did here in class, assuming that you have B minus cancelled or B minus not cancelled, put it direct and indirect at the same time, and this will be your assignment for next lecture.
3.6.
The same problem that we did. You open the slide, the same problem that
You
we
fix
did.
it for one.
Yeah.
Use it. Use it.
By direct and indirect.
Yes, because you have the results also on the slides, the curves, so you are able to see if you are doing this correct or not.
For what session?
Sorry?
For what session?
The
Deadline next week, as usual. 1 week.
It's-
Not 1 week and 4 days and 5 days and another week. Okay? Only 1 week. 1 week you change your program, you just add the design parameter in the program that you sent me before,
Wednesday.
and then you open. You have the same algorithm in the book, by the way. Look into the book, look into the algorithm is fine with me, as long as you understand the sequence. You are able to solve any problem with that. Alright? What I will do with you next time is, I would like to ignore everything about identification. I would like to do adaptive, but without identification. Right? So I don't want to do identification at all. And we are going to start, right now we are working with input-output systems. So we are focusing on Y and U. So next method that we are going to see will allow us to find adaptive controllers without identification at all, completely out, and from input-output point of view. So still we are looking to single input, single out. Everybody's okay with this? Later on, we are going to ask the question, what happens if we have multi-variable system? And then we move to Lyapunov-based design. Is it clear what I said here?
Yeah.
All right. خلاص. Thank you very much. See you inshallah Sunday.